a small session today. We only have 1 hour, so I will give brief you something lah. Okay, at least you can start gathering information about your group design. So previously we have done how to define the problem. Okay, you found out what is the go-kart standard, what is the normal sizes, what is the weight of the driver. Normally they will have there. If not, then you taken this week to find out, right? If you haven't find out what is the go-kart standard, what are the driver, what is the effect of driver weight or not, right? But based on the standard, it's just on the vehicle weight and engine power. Okay, so if you are not sure, go and find out. Okay. All right. Now today we're going to look at second component of conceptual design, which is gathering information. We move into second steps in the conceptual design, gathering information. Now, what do you do when you gather information? So when you reach the second steps, means you're able to create a statement that describe what the customer want. Okay, means when you create your report later on, in one of the chapter in your report, you need to identify what is your problem statement. Okay, problem statement, basically you write what is the issue you need to solve. Okay, in this case you are designing a go-kart, so you are going to write what you're going to find out what is the design parameter, what is the go-kart standards that fit into your design. Okay, and the need of customer here is your lecturer. So basically the projects in Capstone Design 1, and we propose, and all of us we agree that we go for the go-kart project. So the need of a customer is basically by Capstone Design 2. When we reach Capstone Design 2, you're going to fabricate it, and you and your team member, you are the end user. Okay, you are the one who sit in the driver's seat and test run it, and even have fun in the campus. So this basically is you, customer. At this stage, your customer is your lecturer, me. But when it comes to in the long run, meaning in Capstone Design 2, this customer is you. So when you design when you design a conceptual design in this semester, Capstone Design 1, think of yourself and think of your partner, right? Think of your group member. You are the one who going to fabricate it and sit inside it and have fun in the campus. So if you come up with a bad design, then you are the one who suffered from the bad sitting. I mean the bad seat and also the bad design. All right. So you are the one who feel whether it's comfortable or not comfortable. Okay. So you are the one who sit in that, and also you will showcase your products even to the universities or the professor and doctor. They're going to be coming to your last presentation of Capstone Design 2, because go-kart is something that can make sounds in the campus, and since we have 3 engine, three go-kart to fabricate, it's going to be a loud sound. Okay, and it's going to be something excited. So you're going to make everyone run up from the classroom and see what you're doing. Okay, so just think about that final day of your products. Okay, so again, at the moment, nobody know yet we are doing go-kart project yet, but when you reach Capstone Design 2, then you'll know. There's a team who are building go-kart in the campus. Okay. When you're gathering information stage, you have to start focusing on the design, engineering design. that have a special requirement. What I mean by special requirement in your case, right? So for Capstone design one, you know that you need to come up with a conceptual design of the go-kart. So in the previous homework, I asked you to go and find out what is the regulation, what is the normal, typical go-kart design, and you're going to use the special requirement for go-kart, especially when you come to go-kart design. Put the special requirement into your conceptual design. Okay, so this is the stage where you get some idea what is the industry practice, how people design go-kart, what are the available go-kart design. They have a special requirement there, right? Even maybe you over design, it become too heavy, or you over design, it become the engine cannot run, or if you fall outside the go-kart category. So you need to find out what is the requirement to be categorized as go-kart. Yeah. So by today or by this week, maybe the latest is by next week, you have to able to tell people what is the difference between go-kart and motorbike, or go-kart and a normal car. Okay, you have to able to tell what is the requirement. Okay, so start from today, you need to gather some information. Next one. After you gather information, you continue in the conceptual design stage. What you do, you generate your idea. After you gather all the information, you start doing some sketching and all this. So conceptualization is the third steps. After you define what you're going to design, you gather information. The third step is to illustrate or draw out the idea. Okay, so again, conceptualization, the definition is to have a lots of option, or lots of concept, a lots of alternative, a lots of idea about solving that problem. Right? Your problem now is to design a go-kart, a working go-kart that's fall under go-kart category. You come up with a few concept in this semester, a few a few concept design of body kit, you come up with a few design. Then in next semester, you choose one final. I mean, in this semester, let's say you have 5 design or 6 design. You choose the best design. Then you become a final design of your go-kart. Next semester, we're going to learn how to optimize it and so on. Okay, so special requirement. The next one, after you have all the concept, what you do, you evaluate, or you do it selection. Evaluate means you as an engineering student, you evaluate not based on cosmetic, but you evaluate based on calculation. You need to use software. You need to know how to use software to do analysis, for example, finite element analysis, structure analysis, and so on. But at this stage, you still don't need to go for software analysis yet. It's just that there are some criteria you need to choose so that you know which one is the good design. Okay. Okay, so this is all the textbook definition. So basically, when it comes to the fourth stage, means you already have a few design to choose, and each design have their own strength. Okay, then after that, you select the one it is closest to your goal, or closest to your solution, right? So we're going to look at what is PDS. PDS is product design specification. So during selection process, you will do refinement. Okay, you choose the strength and weakness of your design. Then you choose the best one. Okay, so during fourth stage evaluation, you will come up with a few parameters that meet your solution, right? Your problem here. Okay, so in this case, back to our projects, your task is to design a go-kart networking. All right. So when you design go-kart, there will be some criteria or important parameter to look at. What is a good go-kart car frame? You need to go and decide. Okay. So this one later you come to this stage. You also go back to this stage where you gather information and you put into the report. Okay. So we have come to conceptual design, the fourth steps. Then what happened in the design review? So design review, means that you ask a important question like, is it possible for me to fabricate this part or not? For example, so I go direct into our go-kart project. During design review process, you ask question, do I able to produce this part or not? Okay, do I able to do welding on this part or not? Okay, so don't think about something very complex like need to do electroplating, need to use titanium, all this. So I already tell you the budgeting in the previous lecture. So choose wisely and review whether it is possible or not for you to fabricate. Okay, so this is a review process. Then the next one I mentioned just now, does it economically worthwhile? Does it fit between your budget or not? Okay, as we agree earlier, I already give you some budget. The one that outside the budget, you need to absorb. So when you come to design, if you want to do something fancy, I have no objection. You want to do something fancy, I have no objection. But again, those costs that outside the budget, you should able to absorb. Okay, that one happen next semester. Okay, so next semester when you meet me again in design this Capstone Design 2, don't complain. When you already decide the design, don't complain. Well, sir, this one's so too expensive, I cannot afford. I already warned you in Capstone Design 1, design 1 already. So don't next semester, don't come and complain to me, sir, it's not doable because too expensive. So this semester, you decide carefully what you want to build next semester. Okay. Again, I don't against those fancy design. You can go wild in your design, but consider the cost. Next one, when you review, you need to look at whether possible you're able to fabricate within 4 weeks time. During the workshop, are you able to complete within that particular month, next semester? All right. So if your process is too complex, then you might able to complete your capstone design too. So also consider when it comes to review process, right? Your evaluation of a concept. Make sure your design is not too complex. Okay, make sure it's not too complex. Yeah. So this also linked to the previous one, means you need to identify the resources that you need, because resources impact your schedule. Resources also impact your economic, and resources also impact whether it is possible to fabricate or not. Okay. But anyway, the sample I show you, the go-kart video that I show you, it is doable, it's doable. But that's why I show you the sample. Okay. So you apply the theory part in Capstone Design 1 and Capstone Design 2. Okay. After we done the conceptual design, these four, under conceptual design, you have define problems, gather information, you generate solution, and then you evaluate your solution. So this one, conceptual design, will be done in Capstone Design 1. After that, you will continue with embodiment design. What I mean by embodiment? Conceptual design will be like a skeleton. It's like you building a humanoid robot. So you start with a skeleton. You start with the the main frame or main structure of the robot. Then after that, you add in the function and the muscles for the robot. That's why we use the word embodiment design. So what do you have in embodiment design? After you evaluate, you will go to you will come into the final design that you want to do, which is in Capstone Design number 2. You will look at product architecture. Okay, you will look at product architecture. You will look at each component in your design. For example, go-kart, you will look at the frame in front, the front frame. You look at the body frame. You look at the real axle forces. You look at the linkage of between your engine and your wheel. Okay, so this is architecture. You will do that next semester. Then after that, you continue with the configuration of your design. You will consider a more complex process. You will do more analysis and you fabricate it. All right. Then you follow by simulation. You will use some simulation tools, for example, ANSYS or SolidWorks, to run analytic investigation on your design. So you assembly the whole thing. You use SolidWorks to run some simulation, some animation, make sure the linkage is there, is the right dimension, and so on. Is able to generate the rotation that you want, especially on the back wheel. All right. This one you are done in next semester, in Capstone Design 2, and then you come up with the drawing and design, and maybe you need to fabricate the you sure next semester you need to fabricate the prototype. However, this is the textbook end process. All right. So for our context, we don't not only stop at the engineering drawing, we will plus fabrication here. Okay, plus a prototype here. Okay, fabrication of prototypes. Okay, so this is our process. We go deep a little bit. So just explain a little bit what is product architecture. So when you come to embodiment design, we will focus more on the function. You make sure that our design function properly. I'll give you an example. For example, this helmet, this composite helmet. So during the embodiment, you convert what you did in the conceptual design. You have a lot of helmet design. Previously, you choose one of design, you choose the material. Then in this case, when you come to embodiment, you look at the function of all the parts. Okay, does it perform the function that you want or not? Okay, so in this case, when it comes to embodiment, you look at the strength, the material selection, the size, does it economic or not? So, so next semester, when you come to Capstone Design 2, you look at the driver compartment and all the component, the linkage, does it logic or not? Okay, next semester you look at more detail about function of each component. All right, so this will happen when it comes to embodiment process. Okay, so this, you can see involve architecture, configuration design, and parametric design. So this basically you will create this one next semester. Okay, next semester you will use a lot of CAD software to generate the concept or to materialize the concept. You need to know how to use CAD software. You're not limited to SolidWorks. You can use any CAD software as long as you done it in the team, and then you generate the report. Okay. Next semester, your objective is to fabricate operational go-kart. Okay. This semester, your main task is to come up with the final design of your go-kart. Okay. So this one, you will save it in next semester using CAD software. But of course, if you want to do it this semester also can, but it's not part of the report for this semester, just for your info. You can use SolidWorks for this semester, but I will not ask for it. You want to show me in a 3D CAD software also can, no problem. But for this semester, it's not a mandatory, right? But next semester is a mandatory homework lah. Okay. Then next semester, what you do, you will convert the 3D model into technical drawing. Basically, next semester, what you do is you have to make sure you understand from the designing part into fabrication, right? So what you're seeing is that next semester you will be busy using CAD software, creating 3D model, creating technical drawing, the boom list and all this, all right? Next semester, or apply what you learn in your CAD module in this Capstone Design. So the next one, you will look at configuration design. Configuration means to determine the features that link the parts together, whether is that sufficient space related to each other or not. I give you an example of a arm, robot arm linkage. So you will do this kind of analysis next semester. Okay, yeah. One of the sample of configuration design, you will run some simulation to make sure that the parts doesn't break when it rotates. All right. So next semester, what you're going to look at is one part in the go-kart will be the linkage of your engine until your wheel. So is there any weak point within that or not? All right. So where is the weak point of the chain? And what is the weak point of your rotational gear? So this one will happen next semester. Okay, so get ready, yeah, mentally get ready. The next one will be sometimes in configuration design stage, you will create a prototypes. If you have a project like you can use 3D printer or like this, so you generate the parts just to show your concept. All right. Okay, so something like that. Okay, something like that, and yeah, later later I will tell you my plan. Sometimes it's too early to tell you. All right, but anyway, this one is under configuration design. what you can do. And then parameric design, what does it mean? It means that you look for the exact dimension and tolerance for your design. So it means dimensioning, right? Dimensioning of your design, the actual dimension and the space between parts and parts. So this one is a parameric design. And one of the function in, if you're using SolidWorks or AutoCAD, one of the function inside the software itself, you have a parameric design, or there's a function you can key in to predefine the dimension or linkage from one dimension to another one. You can key in the formula, right? Another one, another word is called rhombusness. Rhombusness. Okay, rhombusness means that does it able to continue to perform as what you design or not? Okay, robustness. So for example, this is a scenario when people test aircraft wing. Okay, so I myself, I'm expertise in aircraft design. So this is one of the industrial tests when it comes to they want to design a new aircraft. One of the tests for rhombusness is that they will test the wing structure by pulling the wing 45 degrees from horizontal. Means all the aircraft that you fly today able to go up at least 45 degrees before break. So this is the rhombusness test for aircraft wing. Okay, so aircraft nowadays is very safe. It can even bend 45 degrees before it breaks. But you won't see aircraft bend 45 degrees in the real case, right? So it's very safe for nowadays. If you sit in the aircraft, it is a very safe aircraft. Okay, so we have go through all the process from conceptual to embodiment design. And the final one will be the detailed design. So this one, yeah, maybe we go through all this for this week. We conclude this one this week. So detailed design, basically your technical drawing. Okay. Technical drawings, when it comes to the last stage, detailed design, we will have all these important keyword. You will see that you're generating 2D detailed technical drawing in Capstone Design 2. Okay, when you reach detailed design next semester. Okay, so when you reach a detailed design stage, you will see engineering design in detail. Then you will do verification of prototype. In this case, you will verify your prototype, your go-kart fabricated in a workshop by field test, meaning we will have a go-kart race in the campus, right? So you will drive your go-kart from the main door, maybe, and then go for a roundabout and then come back, right, to make a round and then stop somewhere, okay? So this is how you verify your prototypes. Then assembly of drawing, you have next semester you have a lot of drawing to draw. So make sure you have you prepare mentally what is going to happen next semester. Okay, and when you design for this semester, Capstone Design 1, always keep in mind that what you did this semester is going to carry forward next semester. Okay. Yeah, inside your engineering drawing, you will have a lot of specification about that particular products. So by the end of next semester, you generate a report about your go-kart design. So you will, in your report, you will come up with your specification of your go-kart design. You'll come up with the body frame, come up with the specification of the material you selected, and all the body parts, very detailed drawing. Okay, so by the end of this Capstone Design 2, basically, you are the expert of designing a simple go-kart. Meaning in these projects, in this Capstone Design 1 and 2 combined together, Basically, you are applying what you learned from your first year until the last module for your program. Okay, so basically you show to people you are able to work as a design engineer. Okay, and it will be a very good profile for you when you go to interview. People like to ask what you do in your universities, in your degree. So I hope this go-kart project can be your selling point when you go into your interview. Okay, at least you are proud. Even you can show photo to your interviewer. Look, this is my teamwork and this is what we do. Right. Okay, I hope you will, by using these projects, you can market yourself better. Okay, and even give yourself more confidence as an engineering student. Okay, so that is what I hope for, and I hope all of you able to cooperate with each other and also cooperate with me so that this project can be a successful one. Okay. What else? Okay, the rest you can read from here. If you work in the industry, when it comes to detailed design, when it comes to your costing, maybe you need to deal externally with your supplier. All right. So for your projects, your supplier is me lah. Okay, your supplier is your lecturer. So as we go on, we will review your project, your drawing, your design. We'll give you recommendation. We'll tell you the limitation of your budget. I keep reminding you. So if you have more resources at your site and you want to share, no problem, right? Okay. So and then the costing is important in all kind of projects, right? You need to able to have a detailed costing. By this semester, Capstone Design 1, inside your report, you should include estimated cost for your projects. Okay, earlier I did show you one sample of what your senior did. So at least you have some idea what's going to happen. Yeah, this one is more when you go to work, they will have a review meeting before they launch into mass production. Okay, they will review all the document and make sure it's safe to use and easy to fabricate before they push your prototype into mass production. Okay. Can we go for a few more slides? Or maybe we save this one for the next. Can okay. So this one you can read from my slides. I think some of at your site, this one seems very blur, but there is a life cycle of all kind of products, meaning from raw material go into the end user, and then maybe some of it go to other place and come back. Okay, so this one you can read my slides later on. Basically, what is life cycle is when you look at life cycle, you can tell the story from where it starts until where it ends. Okay, where it ends, the end stop will be including the retirement or the disposal of the product. Okay, so when you're designing your go-kart, I want you to see it from the start. Right, what material you need, how you do it, and then when you present it, you fabricate it next semester. Is your go-kart able to last longer? Means, does your go-kart able to showcase and put in the lobby? Maybe we can showcase it for the next generation, right? Maybe you'll become generation 1, and then each year we will have improvement based on your design, based on your group design. Okay, so means every year, every batch of Capstone Design, maybe we'll look into go-kart project, and maybe some days, I don't know, if we have big enough numbers of go-kart and expertise in go-kart design, then maybe multiple campus will be the will be the place for go-kart. Maybe people think of go-kart, they think of Manipur, and maybe they think of you because you are the first batch in Manipur who do go-kart, right? So I don't know. This one will happen in 5 years, 10 years, we don't know. But this is our vision. So I hope we can continue the tradition. The important for this Capstone Design 1 and 2 is application of what you learn and having fun with engineering knowledge. Okay, so in my class, I want you to have fun. I want you to experience it in a safe way, in a scientific way, and then, yeah, the experience can pass on and pass on. Okay, another one is that, so life cycle is from the end, start to end. So when you design something, you need to consider the lifetime. Okay, the next one is regulatory and social issue. This one also be part of your Capstone Design 1 report, where you need to consider the standard and specification. For example, for go-kart, what is the rules of go-kart? Why can the go-kart go on the road? All right. So on the racetrack, what is the rules? For example, that one. Okay. Where can you drive go-kart? Okay. Or in the go-kart, is there any pollution happen or any issue happen? Okay. So this one you need to find out. Or one of it, I give you an example. Testing standard ASTM, when you design, when you do welding, when you do your design, for example, welding, there are some standard there. And another example when it comes to your design, right? So one of it is ASTM standard, ASME, American Mechanical Engineering Standard, OSHA, Occupation Standard. So this one, when you go to work, is very important to make sure you are work in the safe and safe environment. Okay, so this one also, do you fabricate your prototype, your go-kart in a safe way? So because you need to use welding and you're using the machining and all this. So all these are related to all the safe and healthy, and the material you choose, does it safe to use or not? Okay. So for Malaysia, we have SIRIM. So I'm not sure whether SIRIM have something linked with go-kart, but you help us to find out when we come to that regulatory and social issues later on. Okay, so maybe this is the area you want to go and investigate. This one I show you already, the Capstone Design project. I show you already the sample of this one. I show you this one also. Okay, so with this, I end the recording. Let me end the recording. Okay, any questions?